Go's concurrency primitives, in particular its channel primitives, make working with streams of data, multiple streams of data, actually very easy. I mean, it's one of the things that Go is best at. But there's one particular pattern, or a couple of patterns, the fan in and fan out patterns, which for the longest time I've stumbled over a little in Go. And in part that was because we didn't have generics. One of the pains of not having generics was every time you wanted to implement for your type a fan in or fan out pattern, you had to do it again from scratch. And every time I come to do that, I always stumble over the same kind of difficulties or confusions. For a little while, for a couple of months, I've had this generics Go package which I've been maintaining, which just has a few simple things in it, which I use repeatedly for working with generics in Go. And given that I am constantly stumbling over fan in and fan out, what I wanted to do is add fan in and fan out once and for all to this library, to this package, so that I never have to think about implementing it ever again, basically. So that's what we're going to do today. Before we get started, I want to be clear, make sure everyone's clear on what fan in and fan out is. And like all good things, all the best things, it starts with an explanation and a very ugly draw IO diagram. Let's start with fan in. Fan in is where you take multiple producers, multiple streams of incoming data of the same type, but from different sources, and then you amalgamate them. You consolidate them into a single stream so that the consumer doesn't need to worry about different sources. It can treat them as a single stream. That's fan in. And we're going to start with fan in. You can imagine producers here could be, databases. They could be queues. It doesn't actually matter. The point is, from the Go point of view, that these will be just channels of typed channels, which take in data and consolidate into a single channel of the same type of data. And then the consumer can just consume that single channel and not have to worry about these multiple sources. With that in mind, let's get started. So we'll start with, as we always should, we'll start with some tests. And we'll start with a test for fan in. Now, what we need to test, primarily, what we need in order to test is these multiple sources. So we don't need databases, we don't need anything like that. Today we can just mock multiple sources. So let's say that for argument's sake, we want, let's say three sources that we want to consume from, okay? For those of you who aren't aware of this kind of syntax, this is a minor micro optimization. Empty structs are compiler constructs so that we don't need to take up any memory with this array. As I say, this is a very minor micro optimization that only becomes important when you're working at extreme scale with Go, but it's a habit I'm kind of stuck with. I don't want to waste memory on balls here, even bits. So forgive me for that. Okay, so let's say that we have our three sources of data. I guess the first thing we want our API for fan in to do, that we're going to offer with this package, is some kind of registration. So let's say that we want to get a channel back that is part of this fan in construct, and we'll figure out what that is exactly in a minute. And we'll call it with a register input. And this basically means, hey, we have a source. Perhaps we'll call it register source. We'll register a source, and then this is going to give us back a channel. This is how I'm thinking about it right now, anyway. This is going to give us back a channel, which we can then point our source at. So then what we want to do is actually make up our fake source. So we're going to do this in a Go routine. We'll do that so that we can run these in parallel. That's one of the important things about Go and about fan in. These can happen in parallel. We don't need to know where they're coming from. And what we'll do is we will just loop over a set of, again, I'll use empty structs, but we'll loop over a set of, let's say, 4 records that are coming from this source. Let's imagine that this is, for example, a database, and we're going to query and we're going to get back 4 records. And for each of those records, they will be written to this input queue. And what we should do here is, because we're going to have 3 of these and then inside 4 of each, let's make something that will show it's unique for the purpose of the test. So what I was thinking of for this is doing some concatenated key where we will just combine I and J. So what I was going to do is write a string which should look, for the very first one, something like 0, 0, and go all the way up to 2, 3. And then we can write a test based on that. So that is, those are our sources. And you can see what we're going to do is, just to summarize, we've got up here 3 sources. Each one is going to produce, for the point of our test, 4 sources, 4 records. It doesn't really matter how many, that's just for the test. A nice manageable amount. And then the last thing, once we've finished writing to the channel for our test, we should close it. One important thing in Go, the writer should always close a channel. The reason for that is that if you try to write to a closed channel, you'll get a panic. So it should always be the responsibility of the writer to close the channel so that the writer knows that it is in fact closed and doesn't try to write to it again. Okay, so that is our, those are our producers for the fan in test. So now we probably want a consumer, and the consumer will kind of be the heart of this package. So we're going to run this consumer within the package. So we probably want to run something like fanin.start, and this will start, we'll implement all of this in a minute, but this will start the consumption process of all of the streams which are producing data, and then begin the consolidation. What this package is then going to output is a single stream, which will consolidate all of the sources up here, all of the sources registered. So probably what it will return is another channel, and this will be the output channel. And then probably, for the point of the test, probably what we want to do is just record them. So let's say they're going to be strings, as we know, because in the test here we're passing a string to the channel. But it will be generic, so the idea is it could be anything. And then what we want to do is push each result to the channel, just so that we can then test it. In real life, you're more likely to actually do something with that channel. So one by one, the elements that come through the channel would be processed and something would be done to them. But for the point of the test, we just want to push them into an array and test that we got the right results. So actually, we don't need this. We just want the value that comes out of this. So we can actually just range over the result here. And then for each result, we can just append to the channel, to the array. So to reiterate, in real life, if you were writing a fan in like this, you would actually be doing proper work here. Perhaps you're processing records from 3 database queries at once, and then you'd be, filtering them or doing something useful with them. In this case, we just want to put them in the array so that we can actually test them afterwards. So that's going to give us an array of strings, a slice of strings. And we want to assert the order of those. Sorry, not the order. We want to assert the content of them, but to do that, we may actually need to think about order in a moment. But what I'll do is I'll write the assertion first, and then we'll have a think about order after. So I'll put a to do here, think about order, not guaranteed. Because we don't know in which order these are going to come through onto the channel. We know that each source will come through, the records from each source will come through in some kind of order, but we don't know which source will get its records in sooner or later, so we can't guarantee order. But let's think about that later. For now, what we want to test is that results have everything we expect. And what do we expect? We expect, and I can write this out, I have to write this out manually, but we expect from source 0, which is this first number, we expect 0, 1, 2, and 3. And then in fact, we expect exactly the same from all the other sources too. So there are 3 sources and we expect each of them to have 4 elements. And that's this. You can see that this pattern matches this pattern here. So that is what we expect our fan in to do, is take multiple data sources and group them into a single data source. Okay, so that's our expectation. We'd start with the test. Now let's think about actually how we might implement this. So if we create a new file, let's think about actually how we might implement this. Now, the first thing we're going to want is some kind of type. So we want the type to be generic. So let's, actually, I think I need a space at that side. I can never remember where, oh no, I'm wrong. I can never remember where the spaces go here. Okay, what we're going to want in there, well, let's think about that in a minute, but let's think first about the API we need to satisfy. The first thing we need on this fan-in type, well, let's create a new fan-in function first, and that's going to return a fan-in. And then we'll think about actually what we need in there in a moment. Yes, and that's a good point. So this will accept a type argument. Let's say that it's any at the moment, like that. And what this just means is the fan-in will take a type any, and the type of the fan-in will be decided by the user. For example, obviously, we'd be using, so I need to register fan-in here, and this would be new fan-in. And our type is going to be string, and the reason for that is, we're testing with strings, but this could be absolutely anything. Okay, so next what we want to do is implement this register source. This is going to be a receiver on the fan-in. Yeah. Do I need that? Yes. And what do we need this to do? Well, we needed this primarily to give us a channel of type T that we can then sources, producers can write to. And so therefore we can create this channel. You create channels in Go with make. You can do it like this. We could actually accept, so you can create a buffer for the channel. We could accept a buffer parameter here. So let's take a buffer parameter like that. We don't actually need this for our test, so let's do like this instead. But a channel buffer means that you can allow a certain number of items into the channel before it blocks to be consumed. And then what we want to do with the channel is save that channel on the fan-in itself. So we'll need a sources array where we push like that, and then we can return the channel. And then what we can do here is store on the type a slice of channels of type T. And then what we know is we can start to consume those. So the next thing we want to do is, so that gives us, what's this error? Expected Boolean or range. Yes, I need to range over this. Very nice. And same here. I always forget the range. Okay, cool. As you can see, the next error that we have is start. So we need to implement the start. What this is going to do is actually begin to consume the input sources, and then it will output to the output source. So the very first thing that we want to do is, well, actually, I think we have this channel returning a channel. So So this has to return to channel 2. And actually there's one note here, something nice you can do in Go. We want these channels to be write only. So we don't want them to be readable by the consumer. So what we do is we use this syntax to say, return a channel that can only be written to. So the source can write to it, but not read. And that partly ensures something we were talking about before, which is that the writer, and only the writer, should close a channel. Now, in contrast, this is an output channel, and we want this to be readable only, which is what this syntax means. This means that the consumer of this package can't close this channel, which is important because we want to be the one to close it internally when we know that we're done writing. And then what start needs to do? Well, start, obviously, as we've said, first needs to return this kind of channel. So we need to make that channel T. We don't need to worry about a buffer for this. And then this is our consumer. So what we really want to do here is loop over the source channels. So what we'll do is, let's say for source in the sources that we've created. Again, I'm forgetting my range statement. For each source, so that will give us a channel. Let's call it source channel for clarity. And for each one, what we want to do is, what do we want to do? Well, we want to loop over the values that we get back from this source channel and write those to the output. Oh, no, V to the output like that. And that is actually pretty much the basis of the fan. Now, there's a bit more to do, but the fan in. This is the concept, okay? We take a whole bunch of channels, and for each one, we write to this centralized channel, a consolidated view of everything that's coming into all of the sources. And yeah, I mean, that's pretty much it, but we need to think about a couple of things here. Firstly, we need to be able to return this output channel. But what you can see is obviously we're going to block on returning that output channel until we finish reading all the source channels. But that creates a bit of a problem because we can't write to the output channel here, which is unbuffered, until it's being consumed. And of course, it's not being consumed by us, but the user of this package. So what we need to do is make this whole thing non-blocking by wrapping it in a Go routine. And what this will allow us to do is start consuming this outside. Actually, we need to declare this first. This needs to go here. But what this allows us to do is then return the channel while we start to consume and consolidate the sources. Okay, so that's the first thing. The other thing is, let's imagine that we have two sources. One of them produces a lot of data, okay, but it's quite quick. And another produces less data, but it's quite slow. What this might do here, what this would do is it would block consuming the second source until the first source is complete. What that could mean is that we would take a very long time consuming one source and then have to consume the other source, sequentially. And if that second source, is slower, we'd have preferred to have done it in parallel. So let's do exactly that, okay? So what we'll actually do is for each source here, we'll do another Go routine, where we'll fire off each consumption, and then we'll all write to this channel. And channels are obviously, concurrent safe, so we don't need to worry about sharing that memory. What we do need to worry about is sharing the source channel memory, and we need to worry about that because if the Go routine fires after the for loop has continued, as it probably will do, what we'd end up with is consuming the last source channel multiple times, which is not what we want. And we can solve that simply by passing in the source channel like that, and then we can't really. I was trying to cheat a little bit, but let's do this instead. Source channel like that. What this does is it captures each loop variable so that we make sure that we consume each channel rather than it continuing the for loop and consuming the last one just a few times. Now we have our tests. We know we have one to do. But I suggest that actually we run these and see what happens. Okay, yeah, that's not the right test library. I want to use, I think, Testify, which is, I've got my Go mod. Yeah, okay. So let's import this instead. Get rid of this off the end. And then I think it's just assert it like that. Yeah, perfect. Okay. Now we've got the same problem in our tests here, which is that the loop variable is being captured. So let's do this, just to make sure that we don't have that same issue of capturing a loop variable which continues and would mean we'd get, 3 every time or whatever. Now, let's give that a go. Yeah, okay, so what we can see is that something here is blocking. So we've got something blocking, we've caught in some kind of deadlock. And one thing that I think it could be is, this is giving us back a channel which we're consuming. And when you loop over a channel, as we're doing here, we're ranging over a channel, that range will continue until we close the channel, which we're not doing here. So we actually need to make sure that we close the output channel once we're done. Except one problem, which is that because this is a non-blocking, we would be closing this output right here before it's even been used, which is not at all what we want. So what we need to do is actually close that in here instead. So we only close it once all these are done, except that these are non-blocking too, so we'd still be closing this straight away. So I think what we actually need is for us to introduce a wait group here, I think. So what we need is a wait group. And what this wait group allows us to do is wait to defer this close until everything is consumed off of all of the channels. That's because we don't know in any of these ones if we're done. We only know if we're done when all of them are complete. Okay, so we have our wait group. What we can do is we can add a task to our wait group for each source, because that's what we want to record. Then inside each source consumption, we can call done on defer, so you always defer done. And that means once we've consumed every record off of our source, we mark the source as done. Then down here, we wait, and we want to wait until all sources have been consumed. And then this will close this go routine and close the channel. And then what that should mean is this should no longer be blocked, because once this fan in output is closed, we should get to this point and start asserting. Let's have another go. And there we go. So actually we've got output there, which is quite good. But I think there's going to be one issue, and we can see that here, which is every time we run this, we get a slightly different order. And that is because of this wait group, because of this to-do that I've left here, which is that the order here is by no means guaranteed. You can see it's coming through source by source. We're getting 2s in order, but we're not actually getting the sources themselves in any order, because we could be consuming these in any order. We don't know. Actually, let me just put a count on here so that you can see, uncache the results. So you can see that we're not getting any order here. So this is what we expected, and this is what we're getting. Okay. Right. So how do we fix that? Well, what we do is, for the purposes of the test, I mean, there's plenty of ways to sort this, but we can just sort the results for the purposes of the test. So what we can do is use the inbuilt sort function to sort a slice. And all we need to do is return which is bigger. So if we return that the first is bigger than the second, why is that not working, I wonder? Because we need to give it a type. Yep, of course. Then what that should do is sort into alphabetical order, and then what we've done here is asserted an alphanumeric order as well. If we run the test on that, what did we get here? We expected this and got this. So actually, I've got this sort the wrong way round because we don't want to sort largest first. We don't want to sort from largest, which is this one. We want to sort this first. So actually, we want to flip that. And then there we go. We have a fan-in library that seems to work, which is quite nice. So let's review what we've got here, okay? We've registered some sources. Each source could be anything. For our purposes, it's just a made-up set of strings, but this could be database rows, it could be whatever. And we've written to those in the background. Then what we've done is we've initiated this fan-in, which we can look at, and started running the consumer. What that's doing is taking all of these sources and consolidating them into a single source, which we get back here, item by item. Just for test purposes, we're pushing them into a slice, sorting them so we can assert on them, and we get a result just like this. So from 3 channels here, we get 1 result. And if we look at the implementation here, we have 2 methods of importance. One, which is to register a new source. This stores the sources so that we can consume them later, and then provides it back to the client. Remember, that's write only. That means that the client can close here, but we can't close in the library. That makes sure we avoid panics. And then the inverse, when we call start, we return this read-only chan. And this read-only chan, which is this out chan here. And what we do is for every single source, inside this weight group here, we consume all of the records in the source. When all of the sources are complete, we close the output, which tells us that this range can close here. This range will complete once it hits that close. And then, as I've said, we assert. I think we're going to stop there. That's part 1 of this fan-in, fan-out series. In part 2, what we can do is look at how fan-out works. So the inverse of this, where we have one source and we want to send it to multiple places, produce it across multiple streams. But for now, that's fan-in. I hope you enjoyed. Thank you for watching. Let me know if you have any questions in the comments. Thank you.